Here we're given the equation of a curve C, and there is some point on the curve where x equals 5, and they want the equation for the normal. The equation for the normal at x equals 5. So the normal is the line that is perpendicular or at right angles to the tangent at that point. So if you imagine at this point, x equals 5, if the curve has a gradient that looks like that, oops, so let's do it like this. If we think of a tangent that just touches the line at that point, then the normal, so this is the tangent. It's a line with a gradient equal to dy by dx. So the normal will be that line that is at right angles to the tangent. Okay, so the tangent is perpendicular to the normal, or the normal is perpendicular to the tangent. So if the tangent has a gradient m1 and the normal has a gradient m2, then m1 times m2 should equal to minus 1. Or m2 is minus 1 over m1. So if we find the gradient of the tangent, we can simply invert it and change the sign to find the gradient of the normal. Okay, and the gradient of the tangent is just dy by dx at the point x equals 5. So we can find the gradient of the tangent by finding dy by dx at x equals 5. So dy by dx is the derivative of that, which is simply 2x minus 3. And at x equals 5, so we substitute 5 in there, dy by dx equals 7. So therefore, the gradient of the normal will be minus 1 over 7. Okay, so once you've found the gradient of the tangent, you invert that and change the sign to find the gradient of the normal. But they don't just want the gradient of the normal, they want the equation of the normal. So the equation of any straight line is simply y equals mx plus c. Or another way to write it is y minus y1 equals m x minus x1. And m is what we just found. M is the value that we just found to be minus 1 over 7. X, or x1, that's the value that we were given in the question, x equals 5. That's the x coordinate of that point. The y coordinate we don't know. So if we're to find the equation of a line, we need to find x1 and y1. So to find y1, we go back to the equation of the original curve, and we substitute the value of x in there to find the value of y when x is 5. So to find y1, we just substitute. So y1 equals 5 squared minus 15 plus 3. So 25 minus 15 plus 3, which is 13. So this value here is 13. So we can then say y minus 13 equals minus 1 over 7x minus 5. So that's minus 1 over 7x plus 5 over 7 plus 13. So that's the equation of the straight line. You can add these two numbers together. 13 and 5 over 7. That'll give you 96 over 7. So y equals minus 1 over 7x plus 96 over 7. Check if this is in the format that they asked in the question. They said in the form y equals mx plus c. So that's y, that's m, that's x, and that's c. And they said m and c are rational. So they don't have to be integers, but they need to be ratios of integers. So these are rational numbers. So that's the answer to part A. It then says find the area between C and the normal line. All right, so the normal line is this line in pink. C is the parabola. And the area between the two looks like it's going to be this. So they want that area there. So to find the area between two curves, what we generally do is divide the region into strips, or try to find the area of a strip, a narrow strip between the two curves. So let me zoom in here. If we think of this as, let's choose green. If we try to find the area of a strip like that, that looks like it has a height equal to the difference between the height of the line and the height of the parabola. It might be clearer if you looked at a strip here. So the height of the strip is the height of the line minus the height of the parabola. So if we called this y of the line, and we called this y of the curve, then this height is yl minus yc. So the area is going to be the integral of y of the line minus y of the curve dx. And we need to find these two limits. We need to find these 2 points. We already know this point is 5, but we need to find this point. So let's try to find where these two curves meet. So what is this point? So to do that, we need to equate the equation of our curve, which is y equals x squared minus 3x plus 3. We need to equate that to the equation of our line, this line, the normal, and that was minus 1 over 7x plus 96 over 7. So when you make the two equal, you find these 2 points. Now this equation should have 2 solutions, one there and one there. So if you rearrange this, let me do that carefully, you end up with x squared minus 20 over 7 x minus 75 over 7 equals 0. And you need to solve that. You can either multiply by 7 or use a quadratic equation, but in any case you'll get two values for x. You're going to get x equals 5 and x equals minus something. That something is going to be that coordinate. And to find the area, so let's just call the other point A. You can find this. So the area will be the difference of the two equations. So you'd say area equals the integral from A to 5 of the line minus the curve. So the line is minus 1 over 7 x plus 96 over 7 minus this, x squared minus 3x plus 3, x squared minus 3x plus 3 dx. So if we just open the brackets, so remember the minus sign applies to each of these. So you need to change all three signs. Now, you need to simplify this, then integrate. So that gives you the integral from A to 5. It's the same numbers we found earlier. I'll just write it out. 20 over 7x. That's the result of this plus that. I think I forgot an x here. Minus. So that's minus, plus, minus. Minus, plus, minus. No, I think that was unnecessary there. Yes, sorry. So this and this give you that. And this and this give you 75 over 7 dx. So now we're ready to integrate. That gives you 20, or we can probably just say 10 over 7x squared plus 75 over 7x minus x cubed over 3 from A to 5. And if you know the value of A, you can just substitute 5 and then substitute A and then subtract, and that will give you your total area. So that's how you would answer this question. Whenever you have two curves and you want to find the area between them, you integrate the difference of the two curves, provided they're both positive. The area is going to be positive. You always need to find the limits of the integration, so you need to find the points where the two curves intersect, and to do that you just equate the two functions.